Here we're going to look at a slightly more challenging example than we were doing before. We have r equals cosine of 2 theta, and we're going to take a look at the shaded region and figure out what the area of that shaded region is. Now the first thing I want to point out is that the actual graph of this, all four of these petals are exactly the same, right? And this is kind of bulbous and these are maybe different shapes, but in general these are four nice little petals. So I apologize for that, but I'm going to do the best I can here. So to figure this out, what I notice is that this graph it starts out when theta is 0, and then it comes up back to 0, and then it goes out, and it comes back to 0, and then it comes out, and it comes back to 0, and so on and so forth. So what I realize is what I can do is if I can just find the points where this thing is going to be 0, if I can find those points where it comes back to 0, that's going to give me a good idea of what these bounds actually are. So if I find the 0 point here, 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 and here, one of those two of those 4 points are going to be our bounds. So how do I do this? Well, I want to say cosine of 2 theta is equal to 0. Well, generally speaking, cosine of pi over 2 is 0. Cosine of 3 pi over 2 is also 0, right? Because, if for a normal cosine function, pi over 2 and 3 pi over 2 are 0. You also get things like cosine of 5 pi over 2. That's another example. And sometimes that's needed for what we're doing here. So ultimately, we want to figure out a case where 2 pi is equal to, or 2 theta. So if 2 theta is pi over 2, that tells me theta is pi over 4. Okay, that's great and all, but that's this angle. That doesn't look like our right case. Well, if 2 theta is 3 pi over 2, that tells me theta is 3 pi over 4. Okay, but that's not our case here either. That's 3 pi over 4. All right, well, if 2 theta is 5 pi over 2, tells me theta is 5 pi over 4. So if theta is 5 pi over 4, well, that is our case here. All right, so that's a good one. And if we continue on, 2 theta is 7 pi over 2, tells me that theta is 7 pi over 4. That's my case here. So then what I need the case where I'm going from 5 pi over 4 to 7 pi over 4. So that is 5 pi over 4, 7 pi over 4. So now I can set up my integral. I can use this formula here. I can say, okay, the area is 1/2 the integral from 5 pi over 4 to 7 pi over 4 of cosine of 2 theta squared d theta. Cosine of theta squared, or 2 theta squared d theta. And you could be done, that would be no problem at all. What I'm going to do here is I'm going to do a u sub. I'm going to let u equal 2 theta, du equals 2 d theta, or alternatively 1/2 du is equal to theta. And then for my substitutions, so now my area is going to be 1/4, because I have a 1/2, and then d theta is going to be 1/2 here. And this is actually going to be 5 pi over 2, 7 pi over 2, because I'm taking theta and I'm just doubling it. Cosine squared u du. So from 5 pi over 2 to 7 pi over 2, hopefully you can see this. This is 7 pi over 2. Cosine squared u du. Why do I want to do this? Well, because I'm about to have to do a double angle identity, and I'd rather not double it again. I guess it's not that big a deal, but it is to me. So I can use that double angle identity to get 1/8 of 1 plus cosine 2u du. Right, so Cosine squared of u is 1 plus cosine of 2u over 2, but we already had a fourth, so that turns into an eighth. And then as we continue on, we get the antiderivative 1/8 theta plus 1/2 sine of 2, u plus 1/2 sine of 2u. And you have this. Now, in the interest of time, I'm not going to solve this. Hopefully you feel comfortable enough in evaluating integral limits at this point, and you're going to end up with the answer that this is equal to pi over 8. Because the sign, when you plug in the signs, it's going to go away. You're going to have this minus that, for this case, divided by 8. It's going to be pi over 8. And so you might ask yourself, is that a reasonable answer? Well, that's actually kind of hard to answer here because you may not be familiar enough with the pedals. But pi over 8 is not an unreasonable answer based on what I'm seeing. But you have to be careful when you do these sorts of things. It can be sometimes be difficult to understand if your answer is correct or not. So more practice will help.